Now in nature or in our engineering application, all flow comes in the category of turbulent flow. No fluid flow come in the category of laminar flow. But we have the analytical formula for laminar flow, which we have just discussed, given by Hagen-Poiseuille. Right. When we see the turbulent flow, then turbulent flow is function of the roughness of the wall. Means at the wall we have rough surface, it is function of the roughness of the wall also. So with the help of dimensional analysis, which we will be studying in our some lecture, so right now we are not going into that much detail. This del P is function of velocity of the fluid in the pipe, diameter of the pipe, length of the pipe. This is roughness, epsilon is the roughness, this average height of roughness, viscosity of the pipe and density of the fluid. Right. So for different type of pipes made with the help of different manufacturing process, we may have riveted steel pipe, we may have concrete pipe, we may have wood pipe, we may have cast iron pipe, galvanized iron pipe, commercial steel or wrought iron pipe, drawn tubing, plastic and glass pipes. We have the equivalent roughness in millimeters. These are the standards. Generally, if pipe is made with the help of rivets, then it will have this kind of roughness, 0.9 mm to 9 mm. If it is a glass, then it is considered as very smooth, and if it is drawn tubing, then it is 0.0015. Right. So this is the concept of roughness, and with the help of these ideas of roughness, we will directly go to Moody chart, because Moody chart was given by Moody in approximately 1952. In this year of 1952, he gave this Moody chart, which is developed with the help of lot of experiments done by him and his predecessor. And he developed these charts. These charts are still being used for finding out the friction factor. So that Hagen-Poiseuille equation can be written for generalized fluid flow, may be written as HF, which is known as head loss, is equal to F length V square divided by 2GD. So F is known as friction factor, HF is known as head loss, L is known as length, V is known as the average velocity in pipe, D is the diameter of the pipe. So for finding out the head loss, we have to use this equation. We can use this equation for finding out the head loss for laminar flow as well as turbulent flow. For that, we must know F. Rest of the terms are known to us. We know the length, we can find out the average velocity, we know the diameter of the pipe. So we need to calculate the F, and then you substitute here and we can find out what is the corresponding head loss. For that, we have a chart which is known as a Moody chart. For laminar flow, with the help of Hagen-Poiseuille equation, we can prove that friction factor is equal to 64 divided by Reynolds number, where Reynolds number is defined as rho V D divided by mu. This can be calculated analytically, or it can be done here with the help of straight line. So this is for laminar flow. For transitional flow, we don't know whether we have a laminar flow or turbulent flow, so we don't have any relationship. But then we have these lines which are drawn for different epsilon over D. Here we have different epsilon over D. This is known as relative roughness. So on this axis we have a relative roughness, epsilon over D, where epsilon is known as average height of roughness, and D is the diameter of the pipe. So for different roughness factor, relative roughness, we have these lines, and if we know the relative roughness of the pipe, epsilon over D, of certain fluid flow in a pipe, then let us say this epsilon over D for our pipe flow problem is 0.006. Then we can follow this line, and Reynolds number, if we calculate the Reynolds number and if it comes out to be say 10⁷, then we get this point, and corresponding to this point horizontally we can see what is corresponding friction factor. Then this friction factor is substituted here and we can calculate this head loss. Now if we observe this graph, then this graph can be divided into two categories with the help of this dashed line on this side and on this side. On this side, the friction factor is independent of Reynolds number. When it is fully turbulent flow, then friction factor is function of only epsilon over d. It is independent of Reynolds number because it is horizontal. So it means a different Reynolds number, it is having same value, but it is function of roughness epsilon over d. But here in this zone, it is function of both Reynolds number as well as epsilon over d. So with the help of this Moody chart, we can find out the friction factor, and that friction factor can be used for finding out the head loss for fully developed